Okay, so just quickly to go through this, the two parameters, as you remember from the lecture yesterday, are the number of trials or the size. So in our example yesterday, it was 4, wasn't it? 4 children in the family, right? Well, here we're selecting 6 people at random from the population, okay? And what's the probability of someone having diabetes? Well, it's 21%, which is the same as 0.21 as a probability. This means that in the whole population, 21% have got diabetes, okay? It's the same thing. Okay, so what we want to do is use this function to compute the probability. First of all, we're asked, what's the probability that none of the 6 individuals have diabetes? So we selected 6 people at random, and what's the probability that none of them have got diabetes? Okay, well, that probability we can get from putting 0 in here, okay, and selecting this. So px is equal to x1. Okay, so that lights up this bar here, which is for 0. It's a discrete variable. Okay, so you can only have 0, 1, 2, 3, 4, 5, 6. And the probability that there are 0 would be 0.243, all right? So what's the probability that all 6 individuals have? Okay, so we just need to change this 0 to 6 and press enter, and it redraws it. Now 6 is so small it doesn't light up. There's no bar here, and in fact it gives us a probability of 0. This is actually, it's not actually 0. It is a small probability. What is that probability? If you remember from yesterday's class, it's going to be 0.21 to the power of 6, right? So 0.21 to the power of 6, you can do it on your calculator easily enough. And I get 8.57 times 10 to the minus 5. So it's going to be 0.0000857, right? So lots of zeros and then a number. So it is small, but it's not 0, okay? It is just a very small probability. Now, I've told you that this RJ is like a calculator, okay? So we could do that manually here. Oops. Or in fact, we can use the command something like, okay, so there's a function called dbinom. Here it is, it's helping me. I just click on that, and then in the brackets I've got to type in some numbers. So it's going to be 6 out of 6, and then the probability is 0.21. Now, R can be quite fussy, but if you leave spaces, it doesn't matter. But if you put a wrong character, like let's say I put a semicolon, not a comma, you'll get an error, okay? Anyway, so the spaces don't matter. We can run this, and this should give us the answer. Here we are, this is what I got. Maybe it's difficult for you to see, but the number I've got here is 8.576 times, 10 to the minus 5. So that is a very small number. Okay, so let's go back to this. If I click back on this, then it goes back to this, the options here, the menu, and what's the next thing we need to do? What's the probability that exactly 2 of the 6 individuals have diabetes? Well, instead of 6, I just put in 2 here, and that lights up this one here, this bar. And what's that probability? It's 2.2 something. Here it is exactly, well, near enough, 0.258, all right? Anyone who got that right?
25.8%.
What?
25.8%.
Okay, 25.8%, same thing, yes. Okay, so that's the probability of exactly 2. All right, now 0.21 is almost a fifth, right? And so if we've got 6 people, you would expect there to be, the mean is going to be near enough 1, isn't it? If you remember, the mean is n times by p, okay? So 0.2 times by 6 gives us 1, near enough 1. So that's why 1 has got the highest probability, okay? So if I type in 1 here, that will give us 0.388, which is the height of this bar, all right? So getting exactly 1, not more or less, has got the highest probability, 0.388. Okay, so that was not what we were asked. We were asked 2, so for 2, it's 0.258. Now the last one is, what's the probability of up to 2 of the 6 individuals having diabetes? So here we've got a range, okay? It's from 0 to 0 to 2, okay? So to do that, we choose this button here, which is from x1 to x2. And we've got to put x1 as 0 and x2 as 2. Press enter. And that gives us this, so it's this area here in colored, the colored bars, gives me a p probability of 0.888.
Can't you use x1 equals 2 and then using the second option?
Sorry, x1 is equal to 2?
Yeah.
Okay.
Then using the
Second option. This is going to be the same. This is the same. Thank you. Okay. So this is, yeah, this is actually quite nice because it's less than 2. That's right. Whereas if I wanted to work out, let's say, probability of between 1 and 3, then this last command would be useful. So you can use either, exactly. So between 1 and 3, let's say, that would light up. That lights up these 3 bars. So between 1 and 3 gives me this probability of 0.737. Okay, thanks. Well done. Good. Okay, so we can use these commands, let's say, to work out the probabilities for exact values using d binom. And okay, actually, I think I'll delete this. We'll just go to, yes, RJ gives the more accurate, exactly. So this is what we did before, and we can do the d binomial for, what was it, exactly 2 if you wanted, and for 0. But what we want to work out is this up to. So up to gives a cumulative probability from 0 up to 2. And to do that, we use the p binom command. P binom, it's this one. And we put in here up to 2, and there are 6, and the probability is 0.21. And I run the command, and it gives me 0.884513. So it gives more decimal places, all right? Probably 3 decimal places is good enough for a probability in general. Okay, so we've got to the end of that. I think what we'll do is for you to go on to the normal distribution, and that's what I was doing today in the lecture. And so this should be easier, right? Fresher in the memory. To do that, we need to go to the distraction again and select the first option, normal distribution. Now it starts off with actually what is the standard normal distribution. It's got a mean of 0 and a standard deviation of 1, right? Here's our nice normal bell-shaped curve. But what we're dealing with in question 2 is a population in the 1970s that had a mean weight for males of 78.1 kilograms. So this is our population mean. So we can put that into here, 78.1. And the standard deviation was 13.5. Now, whatever numbers you put in, this shape stays the same, all right? It's just the scale changes. Okay, so you notice this is exactly what we had when I had 0 and 1. I put in 78.1 and 13.5. It gives the parameters up here just to remind me what I've typed in. And actually similar to what we've done in part 1, in question 1, we can work out the probability of getting an exact, well, less than, so working out the tails. It's like the distribution in that standard normal table that I showed you, okay? But this does it for you automatically without having to use the table or do any calculations. So it's nice. So you want to use this, compute the probability, okay? So less than or equal to, if I put in the mean here, it should give me 0.5. Let's just check. Yeah, that's working. So I've put in, calculate the probability less than 78.1. So that gives me this area, which is 50%. But you've got to do it for particular values, right? So for a randomly selected man weighs less than 60, so you'd put in 60 here instead, and so on. So I'll let you play with this. The last couple of questions you may have difficulty with, so C and D. I'll let you get on with A and B, and those who are fast enough can do C and D, or try and work it out anyway, okay? Got to remember that the whole curve adds up to 1 or 100%, okay? So if you subtract a bit from it, a tail, then that gives you the remaining area, okay? So some of these calculations involve, certainly C and D can involve subtracting. Okay.
The very first question is 720.
Sorry, first question is, what is the probability that a...
No,
sorry.
The RJ, the factorial.
Huh?
The factorial one.
Yeah, right at the beginning, yes, 720, yes, correct. Okay. Okay, I will pause the recording now for while we work this out. I'm sorry. Okay, sure. There. Sure. Let's check. Okay. Sorry. The answer of part C, 0.195. Part C, this one? Oh no, this one.
Yeah, I think he's right. She's right. I think the answer.
No. Yeah. Okay. Any other questions? Okay. So you're Sahib.
Yeah, that's right.
Muhammad or Sahib?
It's actually official Muhammad Salim, but people call me Salim.
Okay. That's why.
That's my last name.
Okay. All right. Good. All right.
So
Great.
they're asking me how to take 5 individuals into account for, I think this is for question.
How do I take 5? Okay. So everyone can see this.
Yeah. As long as it says
Says everyone. Yeah. Good. Okay. More questions?